part of Louisiana Pacific, which is a large building products corporation. Our plant is located in Toledo, Ohio. It's part of the Specialty Products Group and Industrial Panels that manufactures interior wallboard, hardboard Class 1, Class 2 hardboard products, decorative tile board, and we're located in Toledo, Ohio. We employ both solvent-based and water-based coating systems to accomplish this via a variety of roll coating applications, curtain coating applications. The product is then dried after those coating applications through the use of high-velocity hot air ovens and infrared ovens to achieve the final cure of the product. The Toledo plant is considered a major source by the nature of the total emissions in our plant on an annual basis, primarily because the volume of coatings that we use and the capacity, future capacity that we have available in our plant. So regardless of how the strategies of our plant are derived for compliance with MACT, we still feel that we'll be a major source even though MACT will be promulgated. LP has a wide-sweeping environmental management system that is really adopted in the company's philosophy from a business standpoint. We believe that environmental compliance and stewardship is one of the foremost business criteria that we try to achieve not only at a corporate level but at a plant level. Our primary coating systems are both water-based and solvent-based. As an example, our Class 1 finishing system utilizes a solvent-based filler, a water-based base coat, water-based inks, and a solvent-based top coat. The coatings themselves are proprietary inerts that contain pigments primarily for hold-out and color. The top coats are, again, primary thermoset resin systems that are activated through a catalyst once heat is applied to the board. The resin systems then provide the type of barriers that we need in a finished product standpoint, depending on what the target market is. The problems in our primary strategy has been to convert from solvent to water in terms of a manufacturing standpoint, originate from transferring of the coating from the container to the actual roll coater or curtain coater that we use to finish the product. Pumps act differently, machinery in water, steel parts rust, bearings have a tendency to seize, pumping equipment itself has some very difficult times in its current state handling water-based coatings when it's been used to pumping solvent. So a lot of the operation needs to be changed and looked at when you go from solvent to water. The most significant thing is that water-based coatings entrap air as they pump without the proper type of pumps being used. So our process was more of a learning curve, getting used to handling the coatings themselves with our current physical equipment. While we didn't have significant cost associated with that change, there was some minor modifications that needed to be changed. As an example, regular steel plumbing needs to be changed to stainless steel or PVC. Bearings may need to be looked at and sealed differently than what we had had historically used with solvent-based coating. So there are some nuances related to water that is different versus solvent-based coatings. One needs to take a look at offsetting the cost increase that there is in purely the price per gallon of the two different materials. And I'm going to talk in generalities here, but on average a gallon of solvent paint may cost $9 to $10 per gallon. The cost of a water-based paint may, in the same physical, with the same type of physical properties, may run $12 to $15 per gallon. At the same application rate, you need to take a look at what your total applied cost is going to be and where other offsets may come in your operation to change from solvent to water so that your total product cost does not increase over that change. In our case, we're able to gain some operating efficiencies in terms of reducing some of the pollution control equipment that we have employed and reduce the use of some of our thermal oxidizers, which greatly reduce the operating cost offsetting the increased cost of the material of a water-based coating. So therefore we felt that obviously in our case it was the prudent thing to do to make that change, because it was, number one, the environmentally right thing to do, and that's the way that our strategies were set for moving away from solvent coatings and solvent coatings that contain HAPs to non-HAPs water-based coatings. The water-based coatings that we currently have changed to were designed with non-HAPs alcohols on a very small percentage of the total coating weight, whereas a solvent-based coating would have 30% by weight of a solvent or totally VOC. The VOC of the water-based coatings would be in a 3 to 4% range versus the 30% range of a solvent-based coating. And in a water-based coating, predominantly the solvents that are used are alcohols, ethanol, isopropyl alcohol, which are non-HAPs at a very low percentage, and the rest of the VOC portion of that coating would then be water. So you're going from virtually a 30% by weight and predominantly a HAPs reduced solvent material to a low percentage of non-HAPs solvents that are used in water base, and those being alcohols. Therefore you don't have a HAPs coating. When we made the change from solvent to water, some of our equipment needed to be changed. For example, some of our pumps and pumping equipment needed to be changed. Primarily the coating equipment itself, our roll coaters, direct roll coaters, pile coaters, curtain coaters remained relatively unchanged. The physical aspect of the coating machines themselves still operated the way that they had when we operated with solvent-based coatings. However, some of the rollers that we use, the application rolls, need to be changed due to the differences in transfer efficiency from a solvent-based coating to a water-based coating. The capital cost associated with that is minor. We had not significant capital involved in the change. And again, our plant was designed with ample drying capacity. It was designed with thermal oxidizers as part of our high-velocity hot air oven, so the aspects of adding more drying to our operation did not enter into our picture. However, I would say that if another person was going to do this, depending on what their line configuration is, there are some drying differences between solvent-based coatings and water-based coatings, which may require the addition of additional drying. However, the technology and the coating chemistry has changed over the years, where it used to be the paradigm that it took longer for water to dry than a solvent. But today the rapid drying water bases that are available today in an acrylic basis dry very rapidly. So in our case, capital expenditures were kept at a very minimum relative to the change from solvent to water. The most significant change that we encountered in making the change from solvent to water was in the cultural change related to the employees and our machinery, obviously adapting to that change. And when I say culture, it's mostly a people change. We were a solvent-based facility for over 15 years prior to the advent of the chemistry changing enough to warrant moving to water-based coatings. In that process, because we weren't 100% converted, portions of our product line were water, portions of our product line remained solvent, so you tried to have the intermixing of pumping equipment, vat systems, use tanks, and the changeover back and forth between solvent and water will add some inefficiency to the production operation. As an example, if you attempt to use the same pumping equipment and vat systems, the change from solvent to water will require various steps of flushing to rid the oil and water aspects of water that does not mix when you have solvent and water-based coatings in the same system. So there's some flushing steps that need to take place, some added time in order to make that conversion. As you move toward more water-based or complete the conversion, the operators actually find that they enjoy working with water-based coatings more so than solvent-based coatings. One of the things that one has to watch out for with the water-based coatings is the freezing characteristics. You'll need to have to evaluate your internal storage capacity for these materials. Obviously, depending on what part of the country that you live in and the distance away from your supplier, the transportation aspect of a water-based coating along with internal storage needs to be considered in terms of do you have the adequate capacity inside for storage. In our case, we added bulk storage internally inside the building to pump direct from the bulk storage tank to the used tank where the coatings were being used in our process. So the coating formulations do contain some alcohols to lower the freeze characteristics of the coating. However, if you're in the part of the country that we reside where winters are below 32 degrees Fahrenheit, they cannot be stored outside, and once they freeze, they lose their ability to be used in the production process. So it's a very important point to consider when changing to water is the storage and the temperatures that are going to be exposed to that coating. Some of the other benefits that we've encountered in changing from solvent to water-based coatings is in developing really better work practices. Because water-based coatings are less forgiving than solvent-based coatings in terms of how machinery adapts to them, our cleanup practices, our maintenance of our pumps and our pumping systems, our VAT systems, the addition of additional flow control that we've added to our operation over time has significantly improved our operation, so that the application of a water-based paint in terms of today's operation provides less process variation than what we had when we were a solvent-based operation or prior to the advent of the changing regulations. So from our standpoint, we feel as though that by going to water we've added better work practices, reduced our operating variation, and thereby reduced our operating cost. In our case, when we converted to water-based, where we have made the conversion, we did not have to add additional drying capacity to our operation. Our plant, fortunately, was built in 1978, and at that point in time the foresight was there to add adequate and ample drying capacity. However, water-based coatings do have some different drying characteristics versus solvent-based coatings, and on a case-by-case basis that's something that would need to be evaluated. Although I think it's been a paradigm that water by itself, it takes longer to dry and evaporate versus the solvent-based coatings. We find that due to the drying characteristics that we're currently achieving with our formulations, that the water-based coatings sometimes dry more rapidly and without as many difficulties as a solvent-based coating. So that's something that the coating formulators and the suppliers can work with individual manufacturers to design coatings that meet existing coating line layouts. However, there may be certain circumstances where that, at least on the drawing board stage, needs to be looked at right on the forefront, because oven and additional ovens may be necessary depending on what the end-use product is. P2 processes that we use in our facility is primarily to control the environment, to help reduce the amount of evaporation that takes place as we transfer the material from the storage tank or the drum or used tank into the vat and then to the machine. The basic things that one would use that operators can help do is to keep lids on containers, to keep vat systems closed, to enclose and put hoods over machinery where fugitive emissions may come from. So in our case, we try to design and have the engineering controls in place to control fugitive emissions. Secondary P2 techniques that we use are closed loop, what we consider closed loop systems, pumping directly from a bulk storage tank to a used tank prior to delivery to a coating machine. This prevents container movement, open drums, open tote tanks or portable totes, the use of temperature to control viscosity rather than several additional containers that may be necessary for controlling viscosity. So we try to use both the normal forms of hoods and containment for fugitive emissions along with closed loop systems for pumping our materials directly from bulk storage tanks directly to the point of use. We find waterborne coatings very effective for our process. We find that the physical properties that are achieved oftentimes have improved the physical properties over solvent-based coatings. As an example, our offline physical properties such as scrape adhesion, gloss, color and hide, flexibility have remained unchanged and in some cases been improved. The whole aspect of our performance criteria that we measure for our decorative products that are designed for high moisture areas has also improved. So with the advent of new technologies and new formulations and changes in the chemistry of waterborne coatings, we found that we actually did enhance our product's performance.